Now here's this expression, x to the power 6 minus y to the power 6, and we need to factorize it. So how can we do it? X to the power 6 can be considered to be x cube whole square minus y cube whole square. So this expression can be written as the difference of squares of two terms. So we have a square here, we have a square here. So square of something minus square of something. This expression has been written as difference of squares of two terms. So we can use this identity, a square minus b square is equal to a plus b into a minus b. So here, this is a and this is b. A square minus b square can be written as a plus b into a minus b. So we can write it as x cube plus y cube into x cube minus y cube. This is a plus b into a minus b. Now x cube plus y cube. This is in the form of a cube plus b cube. And x cube minus y cube, this is in the form of a cube minus b cube. Now we know identities relating to a cube plus b cube and a cube minus b cube. So we can use these identities for factorizing these terms further. So let us factorize these terms further. X cube plus y cube, using this, it can be written as x plus y into x square minus xy plus y square. X cube minus y cube, using this, it can be written as x minus y into x square plus xy plus y square. So this is the factorized form of this expression. So x to the power 6 minus y to the power 6 has been factorized to get this. This is the factorized form of x to the power 6 minus y to the power 6, and we cannot factorize these expressions further. Now there is one more way in which we can factorize x to the power 6 minus y to the power 6. We can consider it to be the difference of two cubes. So x square whole cube minus y square whole cube, and we can use this identity. So we consider x square to be a and y square to be b. Now we can apply this identity. So this gives us a minus b, that is x square minus y square, into a square. A square is x to the power 4 because that is x square whole square, plus ab is x square y square, plus b square is y square whole square, that is y to the power 4. This is what we have. Now this is x square minus y square. We can factorize it using a square minus b square. So this can be factorized using a square minus b square. Now what about this part? This is x square whole square. This is y square whole square. And this is x square into y square. So if we consider x square to be a, then this is a square, this is b square, and this is ab. Now if we add and subtract an ab from here, we get 2ab, and we have to subtract an ab because we are adding an ab term here. So this part is of the form a plus b whole square, and this we are left with a minus AB here. So let us do this to this part of the expression and see what we get. So we factorize it to get x plus y into x minus y. X square minus y square has been factorized to get x plus y into x minus y. And we write this as x to the power 4 plus 2x square y square plus y to the power 4 minus x square y square. We have added an x square y square term and subtracted an x square y square term. Now we have x square whole square plus 2x square y square plus y square whole square. So if we consider x square to be a and y square to be b, we can write it as a plus b whole square. So we can write it as x square plus y square whole square minus x square y square. We can write it like this. Now, this is again in the form of something square minus something square, because this can be written as xy whole square. So something square minus something square. We can again use this identity, a square minus b square. So what do we get? X plus y into x minus y, a plus b. So a is x square plus y square plus b. b is xy into a minus b. So a is x square plus y square minus b is xy. So this is what we have. X square plus y square plus xy into x square plus y square minus xy. So this is the factorized form of this expression. This is the same as we had got earlier by considering the square first and then factorizing. But that was much simpler as compared to this. Now one question might have come to your mind as to, we had an a square plus ab plus b square term here. So let us write it down. We had an a square plus ab plus b square term here. We made it 2ab by adding and subtracting an ab. So we made it a plus b whole square minus ab. Now when do we do it? Should we always do it whenever we have an a square plus ab plus b square term? No. You should not do it always. It should be done only when ab is a square term. So you can see if ab is a square term and you manipulate it to get a plus b whole square minus ab, you'll have something square minus something square. Now again, that something square minus something square can be factorized using this identity. So whenever AB is a square term and you have a square plus AB plus B square, you can make it a plus B whole square minus AB and factorize it using a square minus B square. So if you see in the last step, we have x square plus y square plus xy. So that is a square plus b square plus ab. Now we do not make it a plus b whole square minus ab, because this ab xy is not a square term. So there is no benefit of doing it and will not be able to further factorize it if we bring it to this form. Same is the case when we have minus ab.